Geothermal energy generates about 10,000 megawatts of the world's electricity, enough to power 10 million homes. And on paper, it seems like a really good idea. Drill a hole, produce steam, and turn a turbine for an endless source of power. In the right location, it can easily overcome limited solar and wind generation. But geothermal energy is reliant on a flash or binary steam system, and this has to be at a relatively shallow depth with a high geothermal gradient. This means you need to reach 150 degrees Celsius in only a few kilometers to be economical. So a volcanic zone like Iceland would make a lot of sense because it's in a shallow drilling area. But this can be very problematic in eastern United States where geothermal gradients only range from 15 to 25 degrees Celsius per kilometer. There are also a lot of unknown variables when it comes to deep drilling, so not only you have to contend with a material challenge, but also deal with instabilities as well. One excellent example of this is the infamous Kola 12-kilometer deep hole. It took nearly 2 decades with a final temperature of only 180 degrees Celsius, and this is well below the gradient average. So it becomes quite evident that geothermal energy production is not a universal thing and is very location specific. But in the late 90s, the US military did research into direct energy drilling, which basically means that it could use plasma or lasers, which would be contactless, but also vitrify or solidify the outside wall without any casing. This means that we can reach these great depths in many parts of the world and provide geothermal energy. But this also means that we need technological innovation with economic viability. Fast forward to 2022 and the Petra Swifty robot was revealed. Using a combination of heat and high pressure, the machine can literally vaporize quartzite, one of the hardest materials on Earth. Even though the company never released the technical specifications on the machine, it did prove that non-contact drilling is possible. They continued on with more commercial variants and have achieved 1,000 meter drilling at a diameter of 11 centimeters. EarthGrid also came out with a plasma machine, which could operate at 27,000 degrees Celsius. This particular robot utilizes an array of torches, which can drill 1 meter holes. Using a high-speed configuration, it can actually drill up to 1 kilometer per day. So it's dramatically faster than a typical TBM. But this very high temperature and speed also means the machine would use an enormous amount of power and would be very comparable to a 10-meter diameter TBM at 8 megawatt hours. GA Drilling has also recently revealed very intriguing technologies. Their anchor bit utilizes 2 caterpillar sections behind the drill bit, with each containing pistons pushing out and gripping the bore shaft. When the upper collar grips, the lower one extends downward closer to the drill, and this stabilizes the bit to about 6 kilometers with conventional drilling, leaving any extra depth to their plasma bit. Once again, this contraption utilizes a rotating electric arc torch to blast the rock with ionized gas at about 6,000 degrees Celsius. But these high temperatures means the plasma bit is very power intensive, with rumors up to the hundreds of megawatts per hour. So it's definitely not going to run off a conventional diesel or gas generator. Nevertheless, they have experimented with several prototypes, and it does show an interesting potential to plasma drilling. But the perfect energy drill would use considerably less power. And this fortunately has been demonstrated by Quaise Energy. They have a microwave drill which can vaporize bedrock without wearing out equipment. The machine would utilize a gyrotron which would send millimeter wavelength microwaves down a very long guide. A gas would clear up the hole and send debris up in an open area around the tube. The gyrotron is a very interesting machine because it's a very high interest to fusion research, so it's definitely interesting to see an offset technology be used in drilling. But more importantly, it only consumes about 1 megawatt hour, so it could be powered by mobile gas or even diesel generator. The company would also utilize a hybrid method, so rotary drilling would be used until the combination of heat and hard rock would become problematic. The company's goal is to power a pilot project by 2026 with a 20-kilometer depth limit at 500 degrees Celsius. That's pretty extreme, and it would essentially be the deepest hole in the world. Now, obviously the biggest engineering challenge of all this is to make a straight waveguide which can reach these unbelievable depths. Ultimately, plasma drilling could work if refined and supplemented with a reasonable power source. But microwave drilling could be a lot more feasible because it's not using as much power. But it does use expensive equipment, so either way, there is still economic problems when it comes to energy drilling. We have definitely made strides when it comes to this type of drilling technology. But more importantly, I would like to know what you think about all this. So please leave a comment, like the video if you enjoyed it, and make sure to subscribe to my channel.